Rectification is a process that changes alternating current to direct current. Rectifier, or also been known as diode, is device that produces the change of AC to DC, and it allows electrical current to flow only in one direction. Rectifier or diode is needed in X-ray tube. Electron in X-ray tube is supposed to flow only in one direction, which is from cathode, heated filament, to anode, which is the target. AC might reverse the polarity, which means cathode will be positive and anode will be negative. So it is possibly because the electron hit the filament, then cause destruction. Therefore, rectifier is used to allow electron flow only during half of AC cycle and block the current when the polarity is reversed, which means AC is changed to DC. There are two types of rectification. The first one is half-wave rectification that consists self-rectification and two-diode. The second one is full-wave rectification that consists four-diode.
I will explain about half-wave rectification. There are actually two types of half-wave rectification, which are self-rectification and two-diode rectification. But first, I will explain what is half-wave rectification. So, as we all know, the function of diode, or also known as rectifier, is to change alternating current to direct current. As you can see from the diagram, if the current moves clockwise, the circuit will be in forward bias, and if the current moves counterclockwise, it is reverse bias. But how to determine whether it is forward bias or reverse bias? Well, the answer is very simple. You just need to look at the arrow of the diode and the direction of the current. If the direction of the current is the same as the direction of the arrow in the diode, then it is forward bias, and vice versa. When it is forward bias, current can flow in the circuit. However, in reverse bias, there is no current flow, means that the current can only flow in one direction only, which is clockwise. So this diode can be said successfully convert an alternating current to direct current. Initially, it's like a waveform, but now we cut off the currents that flow backwards. So this type of rectification is called half-wave rectification. Because why? Because just half of the wave remain, the other half is cut off already. So the final waveform on the screen is a positive half only of the original SC waveform. Okay, now we move on to half-wave self-rectification. During the first half cycle, the anode is in positive in relation to the cathode, so current flows and X-rays are produced. However, in the second half cycle, the anode is negative, so there is no current flow and no X-ray production. This is what we call self-rectification, because the tube does its own rectification and is half-wave rectification since only half of the current wave is used. However, self-rectification is usually limited to dental and portable units, and the highest limits are about 30 mA and 90 kV only. Next is two-diode half-wave rectification. Remember when I said there is a heating problem in self-rectification? Here is the solution. The insertion of two solid-state rectifiers into the secondary circuit of the high-tension transformer overcomes some of the heating problems of the self-rectified. Temperature of the target can be allowed to rise near the melting point of tungsten. It will allow an increase in the applied load of about 50%.
Last sekali adalah full wave rectification. So full wave rectification is a circuit which converts an AC voltage into pulsated DC voltage using both half cycles of the applied AC voltage. So full wave rectification can be found in most modern X-ray generators. Both half alternative voltage used to produce X-ray. Berbeza dengan half wave rectification, satu kita utilize, satu kita suppress. Tapi dalam full wave rectification, first half cycle kita guna dan second half cycle pun kita guna. Kalau kita tengok pada sinus graph tu, so semua half cycle berada di bahagian atas, berada di bahagian positif. Maksudnya kita menggunakan semua half cycle. Dan nak menghasilkan full wave rectification, kita kena gunakan 4 diode. Seterusnya kita akan tengok macam mana electrons flow in one complete cycle. Memandangkan dalam litar X-ray ni, X-ray generator, kita gunakan AC current. So maksudnya terminal akan sentiasa berubah lah. Contohnya kita ada situation A dan situation B. So kalau situation A, X adalah negatif, Y adalah positif, disebabkan kita guna AC current, so terminal tu boleh bertukar. So X yang akan jadi positif, Y boleh jadi negatif. Sebab itulah kita akan ada dua situation, sebab kita guna AC current. So bila kita tengok pada situation A, di mana X adalah negatif, Y adalah positif, so kita tengok X negatif, Y positif, elektron mengalir daripada negatif ke positif, bermaksud daripada X ke Y. So secara kasarnya kita boleh nampak dia akan mengalir clockwise lah, mengikut arah jam. So sangat penting untuk kita tentukan dulu terminal bagi setiap komponen yang ada dalam litar tu. Contohnya untuk diode dan X-ray tube, so ada negatif dan positif. And then barulah kita boleh tentukan electron flow dia macam mana. So electron flow mestilah bermula daripada terminal X. So bila jumpa dua junction macam ni, kita electron flow mesti sentiasa masuk daripada negatif dan keluar daripada positif. So mestilah electron flow akan mengalir dalam diode yang pertama. Sebab diode yang pertama, pintu masuk dia negatif, pintu keluar dia positif. Sama juga untuk junction seterusnya, kita ada X-ray tube dan diode yang ketiga. So X-ray tube adalah terminal pertama dia, pintu masuk dia adalah negatif. So electron flow boleh mengalir dalam X-ray tube. And then kalau kita tengok diode yang kedua dan diode yang keempat, kedua-duanya pintu masuknya adalah negatif. Tapi disebabkan diode yang keempat menghala ke terminal Y, so electron flow akan mengalir dalam diode yang keempat dan seterusnya ke terminal Y lah. So pergerakan electron flow yang ada kat dalam X-ray tube tu menyebabkan half cycle kita akan utilize to produce X-ray. So maksudnya dalam sinus graph kita akan satu lengkung ke bahagian positif yang akan dihasilkan, yang menunjukkan bahawa kita utilize half cycle yang pertama. So situation B, X adalah positif dan Y adalah negatif. So sama, electron flow akan mengalir daripada negatif ke positif. So ia akan bergerak secara anti-clockwise. So bermula sama juga, kita tetap kena tentukan terminal untuk diode negatif dan positif dan X-ray tube, and then baru kita mulakan electron flow kita. So electron flow kita mestilah bermula daripada negatif. So maksudnya bermula daripada terminal Y, akan masuk dalam diode yang ketiga, and then pergi ke X-ray tube, and then masuk dalam diode yang kedua, lepas tu terus kepada terminal X. So dalam situation B juga ada electron flow yang berlaku dalam X-ray tube, bermaksud akan half cycle yang kedua pun kita akan utilize to produce X-ray. Jadi dalam sinus graph kita akan dapat second half tu lah. Maksudnya the second half cycle tu pun kita akan utilize. So kita akan dapat lengkungan yang kedua pada bahagian positif.
To summarize, half rectification only utilize half of the available cycles, and X-ray is produced during use cycles. For self-rectification, no rectifier is utilized since the tube itself produces its own rectification. Self-rectification is lowest in price but limited of MA capacity and can cause destruction of the tube. This is because in some cases, inverse current can occur due to electrons from anode hit the cathode, which is the filament, then cause destruction of the tube. Then, for two-diode half-wave rectification, two diodes or rectifiers are inserted into secondary circuit to overcome heating problem. For two-diode half rectification, if one of the diode broke, the X-ray tube still can function normally. For full-wave rectification, four rectifiers are utilized and both half cycles of the applied AC voltage is used to produce X-ray. A Calculation number 2. For the first question, 50 Newton is applied, the distance is 3 meter and the angle is 30 degree. So work done formula is work done is equal to force times distance times cos theta. Therefore, for this question, work done is equal to 50 Newton times 3 meter times cos 30 degree, which the value is 0.866, and the final answer is 129.9 joule of work is done by the applied force. Second question, mass of the loaded cart is 3 kg, height of the seat top is 0.45 meter. So potential energy is equal to mass times acceleration due to gravity times height. Therefore, for this question, potential energy is equal to 3 kg times 9.8 times 0.45 meter. The final answer is 13.23 joule. Next, 14.7 Newton is used and the distance is 0.9 meter. Work done is equal to force times distance. So work done is equal to 14.7 Newton times 0.9 meter. And the final answer is 13.23 joule.
Now, I'm going to explain the calculation for question number 3. So, the question wants us to find the resistance of the identical wire of different length. Since it is identical, we assume that the area and the resistivity is the same. So, we can simply use the ratio method. As you can see, the ratio of resistor to the length of wire is actually 8:1. By using this ratio, we can get the answer by multiplying the length of wire with 8. For question A, the resistance of 10 meter of wire is 80 ohm, and the resistance of 25 meter of wire is 200 ohm. And lastly, the resistance of 2.5 meter of wire is 20 ohm. So for question 4, it is given that R1 is 8 ohm, I1 is 0.2 ampere, and R2 is 4 ohm. It wants us to find the voltage and current passing through R2. So, by using the formula V equals to IR, we get the answer for voltage is 1.6 volt. Since R1 and R2 are parallel, means that the voltage is same in both resistors. Therefore, V2 is 1.6 V. To find the current, just use the formula I equals to V over R. Then we get the answer for the current, which is 0.4 ampere.
Soalan kelima, what is the capacitance when Q equal to 60 microcoulomb and V equal to 12 volt? So sekarang ni soalan nak kita cari capacitance, tapi nilai Q dah dibagi dan nilai V dah dibagi. So formula untuk kita cari nilai capacitance adalah C equal to Q over V. Jadi kita substitute nilai Q dan nilai V yang dah kita tahu tu. So kita akan dapat nilai capacitance ialah 5 microfarad. Last sekali soalan yang ke-6. So dalam soalan ni, soalan nak kita cari dua nilai. So nilai yang pertama yang soalan nak suruh kita cari ialah nilai VS, di mana nilai NP dah dibagi, nilai NS dah dibagi dan nilai VP pun dah dibagi. Dengan nilai-nilai yang dah dibagi tu, dengan info yang kita dapat daripada soalan tu, kita boleh keluarkan satu formula iaitu VP over VS equal to NP over NS untuk mencari nilai VS. Jadi kita substitutekan nilai NP, NS dan VP dalam formula tu. So kita akan dapat nilai VS equal to 625 volt. So yang kedua, soalan suruh kita cari primary input current iaitu IP. So nilai IP soalan suruh kita cari, tapi dalam soalan pun soalan dah nyatakan nilai bagi IS iaitu 12 ampere. Jadi berdasarkan nilai yang dah kita dapat tu, so kita boleh gunakan formula VS over VP equal to IP over IS equal to NS over NP. Dalam kes ni saya nak gunakan nilai I dengan N. So saya gunakan IP over IS equal to NS over NP. Jadi kita substitutekan nilai NS, IS dan NP. So kita akan dapat nilai IP equal to 30 ampere.